I just have the other part of the engineering mechanics. This is statics. So usually for statics, we can solve problems using the three equations of equilibrium. That is, we have the summation of forces vertical equal to 0, summation of forces horizontal equal to 0, and the summation of moments equal to 0. So let's have this example. So this is a passboard exam for civil engineering. Two forces applied as shown to a hook support, and the magnitude of P is equal to 600 newtons. Determine the required angle alpha if the resultant are of the two forces applied to the support is to be vertical. So there are cases that maybe the selection of forces will not be convenient as a solution to a problem. If we have few number of forces involved, we may use a force polygon, basically a force triangle. So based on the given, let us create a force triangle. According to the problem, the resultant should be vertical. So let's say more likely that the resultant is upward. So let's say this is R. So we have this 900 newtons with respect to horizontal. Its inclination is the angle alpha. Then if we are to close the force triangle, we have the force P. Let's say this is the force P, which is equal to 600 newtons. That will close the force triangle. If we are to extend this 900 newtons, this angle is the same as the 45 degrees. So this will be the equivalent force triangle of the 900 newtons, 600 newtons P, and the equivalent resultant of the two, which is, according to the problem, it should be vertical. So if this is 45 degrees, this is a straight line. What should be this angle? That will be, we have 180 minus 45 degrees. This is 135 degrees. So we can now compute for the resultant. So using cosine law, the resultant is r squared. We have 900 squared plus 600 squared minus twice of 900 multiplied by 600 cosine of the angle in between 135 degrees. So what will be the value of the resultant? We have this 900 squared plus 600 squared minus twice of 900 by 600 cosine of 135 degrees. Then square root. So we have that as 1390.567 newtons. That is the resultant. So why did I compute for the resultant? So that I can compute for this angle. Let's say this is theta. So by sine law, that is the same as 600. What is the opposite angle of 600? That is the sine of angle theta equal to the resultant. We have the computed value 1390.567. Sine, the opposite is 135 degrees. So let us compute for the value of the theta. This is the same as 600, sine of 135. Divided by 1390.567. Then shift sine. So we have that as a 764 degrees. Okay, now since we have now theta, how to compute for alpha? So this is 90 degrees with respect to horizontal and vertical. So obviously, we can compute for alpha as 90 degrees minus the value of theta. So we'll be having the value of alpha as we have 90 degrees minus 17.764 degrees. So the value of alpha, so we have 90 minus 17.764 is equal to, we have 72.236 degrees. So in our choices, the nearest value is letter B, 72.24 degrees. So this is one pass board exam problem for civil engineering. Okay, next let's have concurrent forces. So the members of a truss are pin connected at joint O. So as shown. So when force number 2 is equal to 6 kilonewtons, determine the magnitude of force number 1 and its angle theta for equilibrium. So if we say if the forces are in equilibrium, which means the summation of forces is equal to 0. So let's say the summation of forces along x is equal to 0, to the right forces to be positive. What are the forces with horizontal components that are to the right? We have this is 6 sine of 70 degrees, okay, plus f sub 1 cosine of theta, okay, minus this one, minus 5, its horizontal component is cosine of 30 degrees. And the 7, okay, this is a 3, 4, 5 slope. So that will be, minus 7, its horizontal component is 4 over 5 equal to 0. So let's have the equivalent of F1 cosine of theta. So we have the value 6 sine 70, okay, minus 5 cosine of 30 minus 7 divided by 4 over 5. So we have that is negative 4.20292. Then we transpose, that will be positive 4.292 kilonewtons. That will be the horizontal component of force number 1. Then we have the summation of forces. This is now along y equal to 0. Assume upward forces to be positive. What are the forces with vertical component? We have this is 6 cosine of 70 degrees plus the 5 kilonewtons sine of 5 sine of 30 degrees minus, okay, we have 7, its vertical component is 3 over 5 minus force number 1, this is sine of theta equal to 0. So let's have the equivalent of force number 1 sine of theta equal to we have the 0.350 2 kilonewtons. So how do we compute for F1 and the value of the angle at theta? So we may have this one, okay, the ratio of F1 sine of theta divided by, okay, we have F1 cosine of theta. So what is the equivalent of F sub 1 sine theta? F sub 1 sine theta is equal to 0.352. That is divided by F sub 1 cosine theta is 4.292. We can cancel the F1, so therefore, sine over cosine will be the same as the tangent of theta equal to 0.352 divided by 4.292. So let's have the angle theta. So this is the same as 0.352 divided by 4.292, then shift tangent. And we have that angle as 4.689 degrees. Then we can now, if we have now the angle, we can now compute for force number 1 using either of the two. So let's say I'll be using this one. We have F sub 1. The cosine of the computed angle is 4.689 degrees is equal to 4.292 kilonewtons. So we have the value of the force number 1. So we have 4.292 divided by the cosine of 4.689 degrees. So we have that as Okay, the magnitude of the force is equal to 4.306 kilonewtons. So this will be our answers. The angle theta, 4.689 degrees, and f sub 1 is equal to 4.306 kilonewtons. So let us check on our choices. Okay, so we have 4.306 or 4.31 kilonewtons, and the angle is 4.689 or 4.69 on our choices. So our answer will be that's letter A. Okay, so another way to solve this type of problem is using the mode complex of our calculator. But first, we need to establish what is the angle that this forces mixed with the positive x-axis. So this is our positive x-axis. So what is the angle made by the 6 kilonewton from this axis we have? That is 20. This is 20 degrees. This is 20 degrees for the 6 kilonewtons. What is the angle from the 5 kilonewtons towards the positive x-axis? This is 180 less 30 degrees. This is 150 degrees. So we may consider angles that are counterclockwise to be positive. So this angle is 53.13 degrees. So the angle it makes from the positive x-axis is 90 plus 53.13, that is negative 143.13 degrees. So for clockwise angles, that will be negative. So what we have to do is determine the summation of the forces and their corresponding angles from the positive x-axis. So we have that is the same as, we may use the mode complex of the calculator, Canon F-789S GA. So this is mode number 2. So we are using mode 2. Alright, so first we have the 6 kilonewtons. This is 6 kilonewtons, then bring out the negative sign. So bring out the angle sign. So the angle sign can be, the angle sign will appear if you are to use the shift of the integral sign. So that will be the same as a shift of the integral sign. Then input the angle, this is 20 degrees. Plus, we have 5 kilonewtons, shift, shift integral sign, the angle is 150 degrees. Then plus, we have 7, that is 7 shift integral sign to have the angle sign. The angle is equal to negative 143.13 degrees. Then let us determine the value. This is 20 plus 5. Shift integral sign, we have 150 plus 7. Shift integral sign, we have negative 143.13. So we're having the result in the form of a complex number, the a plus bi. And that value is equal to 4 negative. Okay, we have that as negative 4.292. A plus 0.352 of I. So we need to convert this one into the polar form. So what is our polar form? That is the R angle of theta. To determine the value of the force that will make the force system in equilibrium. So all you have to do is shift ups. How we do? This is shift ups. Then number 1. Number 1 corresponds to R angle theta or the polar form. Then press equals. We have the value of 4.306 and its corresponding angle is we have 175.31 degrees. wherein this 4.306, that already is our F number 1, 4.306 kilonewtons. Okay, but if we are to observe, okay, what is the equivalent of 175.31 degrees if we are to plot this one in our in our quadrants? So 175 is almost 180. So let's say this is and it is positive 175.31 degrees. But okay, if we have this value, always take the opposite direction. If you are to take the opposite direction, okay, that is the actual direction of F1. Okay? So always take the opposite direction of the value taken from the mode 2 or the mode complex. If this is 175.31, this angle is the same as 4.69 degrees. And this angle is our, the theta, is the value of theta. This angle is the same as this one. So we have the same value of 4.69 degrees. So this will be our answers, 4.306 kilonewtons and 4.69 degrees. The same values as the previous procedure. Alright. So let's have this problem. So several problem like this or similar to this problem appeared on our board exam. So 3 identical cylinders are stuck within a rigid bin as shown in the figure. So weight of each cylinder is equal to we have 500 newtons. So there is no friction at any contact surface. Which of the following most nearly gives the force at point B? So the force at point B, since we are to assume that it will be a normal force or perpendicular to the surface. Let's say this is R sub B. So to compute for R sub B, we are to compute for the transferred force from the 500 Newton cylinder on the top of this 3 cylinders. So if we are to connect the centers of these 3 identical, we'll be forming an equilateral triangle. So let's say this is the reaction. Let's say reaction number 1. Reaction of the cylinder to the weight of this cylinder. The same on this side. Since they are identical, if this is R1, this is the same as R1. And they are forming equilateral triangle. If we are to draw the equivalent free body diagram of the forces, let's say this is point 1 and the center of this cylinder will be point number 2. So we have the downward force, 500 newtons, will be counteracted by these 2 cylinders. Equal reaction since we have similar cylinders or identical cylinders, R1. What will be the inclination of this axial force? Since equilateral triangle, the inclination will be equal to 60 degrees. Okay, if we are to do summation of forces, vertical equal to 0, upward forces to be positive. That is twice of R1 to R1. Vertical component is sine of 60 degrees minus the weight of the cylinder on the top. Let's say this is 0.1 minus 500 equal to 0. Let us compute for R1. So this is the same as 500 divided by 2 divided by sine of 60 degrees. So we have 288.675 newtons. That will be the reaction of these 2 cylinders carrying this cylinder on the top. How do we compute for joint B, the reaction at B? We may proceed at this joint, let's say joint number 2 or point number 2. So at point number 2, let us do the free body diagram. What are the forces acting at point number 2? So we have the weight of the cylinder. At point number 2, the weight is equal to 500 newtons. We have R1 passing through point 2. Our assumption at point 1, it is upward. If we are to move now at to point 2, we should assume it downward. So, I take the opposite direction this time. This is R1 equal to 288.675 newtons. And the inclination is equal to 60 degrees. Supposedly, we have this reaction under this cylinder. So, let's say this is reaction number 3. That is R sub 3. And we have the reaction on the wall. This is the reaction at B. So maybe, I think we don't need R number 3 since all we have to do to compute for the reaction at B is by summation of forces, horizontal equal to 0. So the right forces to be positive. That is the same as the reaction at B minus horizontal component of this force, that is equal to 288.675, okay, cosine of 60 degrees equal to 0. So we'll be having the reaction at B of the wall. So it's equal to 288.675, okay, cosine of 60 degrees. So we have that as 144.338 newtons. So let us check on our choices. Okay, we have 144.3 newtons. We have letter. It's letter B. So let's try this one. So a 10 meter boom supports 100 Newton load as shown in the figure. So which of the following most nearly gives the value of the actual force in the boom? So we are looking for the actual force on this boom. Okay, so how do we compute for that? Unluckily, we don't have the value of this angle, so we cannot do the equation of summation of moment supposedly. Okay, so if this is alpha, let us first determine the value of alpha and beta. They are needed to compute for the values of the force, the value of the force F. If this is alpha, the distance between these two supports is 10, and the length of this boom is also, okay, according to the problem, that is a 10 meter boom. Therefore, it is the same that we have this triangle. So if this is 10 meters, this is also 10 meters. If this is alpha, basically we have an isosceles triangle. So this side is equal to this side. If this is alpha, opposite is 10, more likely this angle is also, okay, we have also alpha. So what is this angle? That is, okay, we have 180 degrees minus, okay, the beta. Okay, 180 minus beta. But for this triangle, what is the sum of this? Sum of the angles of this triangle? 180 minus beta. It should be alpha plus, okay, alpha plus the 180 degrees minus beta. Okay, well, what is the sum of the angles of a triangle? Should be equal to 180 degrees. So we are cancelling this one, 180. We transpose beta, which means beta is equal to alpha plus alpha, twice of alpha. That will be the relation of these angles. Alpha is equal to twice of beta. Beta is equal to twice of alpha. So let us now form our force triangle. Okay, we have, okay, the actual, okay, if we are to cut this, since this is a pulley, more likely, since that is the purpose why is it, the force is given as 200 newtons. If we are to cut this cable on this portion, this is the same as 200 newtons. So let us make the force triangle for 200, 100, and the axial force. The inclination of the axial force is a beta. The inclination of the axial force is a beta with respect to horizontal. So let's say this is, that should be beta. Okay, let us, for equilibrium, we will make a closed force triangle. And this is the 200 newtons. And its inclination with respect to the horizontal is alpha. Okay, for equilibrium, and we have the downward weight, which is the 100 newtons. So this will be our force triangle. So as you can see, we have the relation beta is equal to twice of alpha. If this is alpha, what is the remaining angle inside this triangle? So beta is twice of alpha. If this is already alpha, the remaining angle here is also alpha. Okay, so let's have a separate triangle. Okay, we have this force. This is alpha. This is the 100 newtons. Okay, this is the 200 newtons. Okay, so we have now two known part, the 200 and the 100 newtons. So we need one more. So what is this angle? That's the angle between the force and the 100 newtons. If we are to observe this part, when we have the direction of the boom, and this is supposedly the 100 newton downward, okay, this angle is beta, which means this is 90 degrees, which means this angle is supposedly 90 minus beta. Okay, so this angle is the same as the 90 minus beta. But what is the equivalent of 90 minus beta? 90 minus beta is the same as 90 minus, okay, what is the equivalent of beta? The equivalent of beta is twice of alpha. So this angle is the same as 90 minus twice of alpha. So by sine law, we can now use sine law. 100 newtons, what is the opposite of the 100 newton side? That is the sine of angle alpha equal to the opposite of the 200 newton side. This is divided by the sine of, we have 90 minus twice of angle alpha. So first thing to compute will be angle alpha. So using Canon F-789 SGA, we can use ship solve. We have the value equal to of alpha is equal to 21.47 degrees. That will be the value of the angle alpha. So can we now compute for the force F? So let us establish the parts of the triangle. This is force F. This is force F. This is the 100 newtons and the 200 newtons. So this is alpha equal to 21.47 degrees. So we have to do this, let's say determine this at theta. So that we can use cosine law to compute for the force F. So the value of theta is equal to, it is the same as 180 degrees minus the alpha, which is 21.47 degrees, minus the 90 times twice of alpha. So you have 90 minus twice of 21.47 degrees. So you have the value of theta, so equal to, We have 180 minus 21.47 minus the 90 minus twice of 21.47. So we have that angle as 111.47 degrees. So by cosine law, we have the force F squared equal to 200 squared plus 100 squared minus twice of 200 by 100. This is the cosine of the angle theta, 111.47 degrees. So you have that force F is now equal to we have 254.245 newtons. 254.245 newtons. Let us check on our choices. We have 254.25. Letter? That's letter D. So let's have this problem. So the rod shown weighs 30 newtons per meter. So therefore we are to place it as a uniformly distributed load. Okay, so let's say this is the weight of the rod. And it is 30 newtons per meter. So which of the following gives the reaction at A? So which reaction? Is it the horizontal reaction or the vertical reaction? We are to include both. So we are looking for, let's say this is the vertical reaction, A vertical, and I'll be assuming that the horizontal is to the right, A horizontal. So let us do summation of. We will do summation of moment about point B. So we have summation moment at B equal to 0, clockwise moments to be positive. So what are the clockwise moments about point B? So clockwise moments, we have this is A vertical multiplied by 10 meters. That is A vertical times 10. Then minus the 30 newtons times 10, its corresponding resultant is obviously midway. So that is at a distance of 5 meters from each end. So we have 30 times 10 times by 5. Minus the vertical reaction of this force. What is the vertical reaction? That is the 12 over 13 of 200 as 60. This is 12 over 13 of 260 equal to, that is the vertical component. How far from point B? That is, we have 4 meters equal to 0. So we include every force. We have A vertical minus 30 times 10 times 5 minus 12 over 13 of 260 times 4. So we have that as 30 times 10 times 5. Then minus the 12 over 13 of 260, multiplied by 4. Then divided by 10. So we have the vertical reaction A sub B, since it is positive, correct assumption is equal to 246 newtons, and its direction is upward. Okay, then we need the horizontal reaction. This is A horizontal. I'll be assuming that it is to the right. So we have, the problem is we don't know yet this tension, the tension on this cable at point B. So let's say this is the tension. How to compute first for the tension? We may do summation moment about point A equal to 0, clockwise moments to be positive. What are the clockwise moments? The vertical component of 260, that is the 12 over 13 of 260. This time from A, there is 6 meters. Plus, okay, the 30 Newton meter times 10, this is the same as 300 newtons at a distance of 5 meters. So that is plus 300 times 5 minus the tension, its vertical component is sine of 30 degrees. This is at a distance of 10 meters from point A. Equal to 0. So let's compute for that tension. We have 12 over 13 of 260 times 6 plus 300 by 5 less the tension sine 30 multiplied by 10. So we have divided the tension as 588 newtons. Okay, so we can now compute for the horizontal reaction at A. So this is by summation of forces horizontal equal to 0 to the right forces to be positive. That is AH. We have A horizontal plus the horizontal component of 260, that is 5 over 13 of 260 minus the horizontal component of this tension, since it is its component is to the left, minus 588. Horizontal component is cosine of 30 degrees equal to 0. So we'll be having the A horizontal. So you have 5 over 13 of 260 and minus 588 cosine of 30 degrees. So we'll be having 400. This is 409.223 newtons. Since the report is reaction at A, we are looking for the resultant reaction at A. Since it is not specified as vertical reaction or horizontal reaction. How to compute for the actual reaction at A? That is the square root of, we have A horizontal squared plus A vertical squared. So we have the value of the square root of A horizontal, we have 409.223 squared plus A vertical, we have 246 squared. So this is the actual reaction at point A. We have the value 477.472 newtons. Let us check on our choices. 477.472. Our nearest value is 477.5 newtons. Alright, so let's have this example for friction for an object over an inclined plane. So a 500 kilogram block is resting on a 30 degrees inclined plane with a coefficient of, so since we are dealing with statics, the coefficient of static friction equal to 0.30. So find the required force P applied. Take note, this force P should be applied horizontally that start the block to move up the plane. So let us first do our free body diagram. So obviously, we have the weight of the block, it is downward. Since it is inclined, we'll be having the component of the weight parallel to the plane. The other is perpendicular to the plane. So this is the weight, sine of this angle is the same as the inclination of the inclined plane, 30 degrees. W is sine of 30 degrees, and the perpendicular component is W cosine of 30 degrees. So since the force P is applied horizontally, not parallel to the inclined plane, it will have its component parallel to the surface and perpendicular to the surface. So we'll be having this is the parallel component and the perpendicular component. This is the same as the angle 30 degrees. So the perpendicular component is P sine 30 degrees and parallel component is P cosine of 30 degrees. So okay, so since we have a coefficient of static friction, we are to consider frictional force. So according to the problem, the block will start to move up the plane. So take note that friction will oppose motion. So which means the direction of the frictional force should be downward. So this is our frictional force, its direction is downward. And okay, lastly, our normal force. So how to compute for the frictional force? That is equal to the coefficient of friction, statics, normal force. If you are to observe, what is the equivalent of the normal force from this free body diagram? The equivalent of the normal force is the weight, cosine of 30 degrees, forces that are perpendicular to the surface. This is one. The W, cosine of 30 degrees. The other is the perpendicular component of the force P. So plus, that is plus P sine of 30 degrees. Okay, we have two components of the normal force. Okay, now, so can we, we are to do summation of, and the summation of forces equal to 0, we assume that the upward ay parallel to the plane, forces upward to the left to be positive. What are those upward forces? We have the P cosine of 30 degrees. Okay, that is the upward force. Then the rest I think the rest are downward. Minus the W sine of 30 degrees. Minus the frictional force equal to 0. This will be our equation. Let us compute for the weight. How to compute for the weight? That is the mass times acceleration due to gravity. This is 500 times 9.81. We have the weight of the block. This is 500 multiplied by 9.81 is equal to 4,905 newtons. What is the equivalent of our normal force? The normal force is equal to the weight, 4,905 newtons, cosine of 30 degrees plus the unknown P sine of 30 degrees. These are the equivalent of normal force and the weight. So let us compute for the force P. This is P cosine of 30 degrees. Minus the weight. This is 4,905 sine of 30 degrees. Minus our frictional force, that is mu statics normal force equal to 0. So we have the force P cosine of 30 degrees minus 4,905 sine of 30 degrees minus coefficient of static friction, we have 0.30. What's the equivalent of the normal force? 4,905 cosine of 30 degrees plus P sine of 30 degrees equal to 0. So let us compute for the force P. So we have that value as 5,204.922. This is everything in newtons. Let us check on our choices. 5,204.92. Closest value, letter B, 5,205 newtons.